Hi, this is Alex from devstories.eu. Deep Agents, episode 15 of 16. Why settle for a generic coding assistant when you can inject your own heavily customized LangGraph agent directly into your code editor? The protocol that pulls your bespoke agent out of the terminal and into your daily workflow is Editor Integrations via ACP. Before we go further, we need to clear up an acronym collision. You have likely heard of MCP, or Model Context Protocol. MCP connects your agent to external tools, allowing it to search a database or read a file system. ACP, the Agent Client Protocol, is completely different. ACP connects your agent to external IDEs, like Z or VS Code. One connects the agent to external data, the other connects the agent to your workspace. ACP is a standardized communication layer. It defines exactly how an integrated development environment sends text selections, file structures, and user prompts to an AI agent. It also dictates how that agent sends back code insertions, file diffs, and chat responses. By implementing this protocol, your custom deep agent behaves exactly like an off-the-shelf assistant inside your editor. The difference is that it possesses all the specific memory structures, custom prompt templates, and specialized internal tools you built into it. To bridge this gap, you install the deepagents.acp package. The integration requires a very short Python script to act as the entry point. In this script, you instantiate your pre-configured deep agent. Then, instead of starting a web server or a command line loop, you wrap your agent in an ACP server interface. You accomplish this by calling a dedicated run function and passing in an AgentServerACP object, which itself wraps your underlying agent logic.
Here is the key insight. When you configure this server, you set it to use standard input and output, commonly known as stdio mode. This is crucial because it means there are no network ports to manage, no firewall rules to bypass, and no WebSockets to debug. The agent process simply listens for incoming text strings on standard input and prints its structured responses to standard output. Next, you must connect your editor to this script. Consider the Z editor as a concrete scenario. Inside Z, you open your user settings JSON file. You add a configuration block instructing the editor to use a custom agent. Instead of pointing Z to a remote REST API endpoint, you point it directly to your local Python executable, providing the path to your new ACP script as the primary argument. When you start a session, the editor spawns your Python script as a hidden background process. Every time you ask for an inline edit or highlight a function for refactoring, the editor sends a structured ACP message through standard input directly to your running script. Your custom agent processes the request, traverses its internal node graph, queries its memory, and prints the ACP formatted response back to standard output. The editor captures that output and applies the code changes natively in your application window. The single most valuable takeaway here is control. By routing your custom agent through ACP over stdio, you stop relying on a generic assistant and start collaborating with an entity that inherently understands your specific code-based conventions.
That is all for this one. Thanks for listening and keep building.